Hello and welcome to the podcast According to Sci-Faith, where we discuss topics revolving around the compatibility of science and faith. I'm Joshua Göcking and you're listening to According to Sci-Faith. Episode 19, The Physics Behind Oppenheimer. So last year, I'm not sure if you have seen it, but last year this movie came out of Oppenheimer from Christopher Nolan. And when this episode comes out, the Oscars were just awarded. But since I pre-record the episodes, I only know that this movie has been nominated for a lot of Oscars. So let's see how many Academy Awards it will win. But I think it was really a good movie. I really liked it. But as it is with such movies about physics, about from the view of a physicist, about an area of expertise, oftentimes the things one is most excited about is not covered there. For one thing, because the movie focuses on different things. I think in this movie, if you have seen it, it focuses a lot more on the politics and the implications of the development of the atomic bomb and less on the physics of atomic reactions and so on. But still, it was a really entertaining movie. But I thought in this episode I can kind of add to that the physics behind the atomic bomb. How does an atomic bomb work, and what are the physical laws behind it, the principles behind it, and also some things that that interests me about, or would have been interesting to me about the Manhattan Project and the scientists behind it. So, as we heard in the last episode, basically what atomic bombs and nuclear weapons work with is, or what they use is basically radioactive decay. And in the last episode, we already talked about this to some degree in order to show it as an example of a theory that where the infinity results of it can be removed in it. And there we saw also this process of a neutron decaying into a proton and an electron neutrino, of course. And this is also what occurs in there, where the process of nuclear fission is used. So in radioactive decay, this occurs spontaneously. Basically, the atom is in an unstable condition and it decays into a more stable one, and by this radioactive decay is emitted. But one can also stimulate that, and this is what happens in nuclear fission, where for example, you use then a neutrino, and you charge it on some of these particles, for example, uranium. Another material that can be used is plutonium. So these are the atoms that can be used for this. And with this shaking that comes from this neutron that is put into this atom, the repelling power of the electromagnetic force of the protons is then becoming stronger than the forces of the nucleus, because they have only a limited reach. And with this, the nucleus is split apart. And what this reaches is not only that then now we have two nuclei, but if one just checks the masses of the first nucleus and the two nuclei individually, you will see that the mass does not sum up. So what does this mean? Does this mean energy is not conserved? No, not at all. As we have learned also before in the last episode from the theory of relativity, energy is mass. E equals mc square, or E equals m if you put c to 1. And this is what's happening here. So the mass is converted into an energy. So actually the inner energy of the coupling of this nucleus is set free in this reaction. And so energy is released. But if you only do this for one atom, this is not really much yet. So you need to do this for a lot of atoms at the same time, or at a short period of time, to really have this impact of a huge bomb. And what is done to achieve this is that when this process occurs, there are also neutrons after this division of the separation of this nuclei is achieved. There are also neutrons that coming out of this process usually, and if one manages to keep these neutrons in some area and even even manages to get them to stimulate other nuclei as the first nucleus was stimulated, then you can have this chain reaction where neutrons are emitted and splitting other atoms and so on, and then this chain reaction happens, and then you get all this energy released, which will in the end lead to such an atomic explosion. And this really releases high temperatures, so it's temperatures in the area of 1,000,000 degrees Kelvin, so it's really hot, and it's even hotter than the energy hotter than the temperatures inside of the sun. So it's really, really hot temperatures. But as it turns out, so it's a really powerful bomb, and it was really devastating in its impact. Also, when it was first tested in the Trinity test in New Mexico, it really is a powerful bomb, and was up to this point the most powerful weapon that was ever invented and ever tested and ever used. But it did not stop there, so there is even a more powerful way to create those bombs by not using nuclear fission but nuclear fusion, and this has been done also later. Also the movie relates to that later they built this so-called hydrogen bomb, or the H bomb. And what is used there is not this nuclear fission, but it's the nuclear fusion. And there you use heavy hydrogen or deuterium and tritium, and they fusion to helium. And what happens there is when these two nuclei are put together to one nuclei to helium, there this effect occurs such that you again have such a mass defect, and with that even more energy than in the nuclear fission is released. And this needs a lot of temperature, or a lot of pressure and really high temperatures. And to achieve such high temperatures and such a high pressure, you actually need an atomic bomb to ignite such an hydrogen bomb. So to ignite or to kindle an hydrogen bomb, you need an atomic bomb. So this shows how powerful this bomb actually is. And when this bomb was first tested in an atoll in the Pacific, this first test was called Ivy Mike, or the bomb was called Ivy Mike. And when it was tested in the Pacific, the island on which it was tested was, after the explosion, completely vanished into the Pacific. So this shows you how powerful such an explosion is and was, and it shows you also that how much more powerful than an atomic bomb that even is. Okay, it's time for a short break. Maybe you have heard of it, but recently Elon Musk told about his new research of his company Neuralink about human brain machine interfaces, where you basically with your brain you can access a computer or a smartphone or some apps and so on, and where they were showing first results of these experiments that they did. What I think is really interesting about this is that my book that you can order now also in English, Alien Thoughts, is really about exactly that topic, about some neurochip that is implanted in the heads of people, and with which they can do similar things, and also with some side effects that occur in those. So what is even more funnier than this, I wrote my book, the most part of my book was really finished before I even know about Elon Musk's company and about what they were doing, and even knew about the name of this. And in the end, if you have read my book, you notice in the end there is some, I think I call it neural connection there, that they have there, and this is something that they use the neurochip for, with which they can do some stuff. So read it if you want to know more about it. But the interesting thing is, in the beginning, initially I planned to call this a neural link, and only when I found out that they were really working on such things and that a company that is working on it is actually called Neuralink, I decided to change the name a little bit to don't make this association to this company. But I really think it's interesting that something that I really had in my mind, only I was thinking about it, and some not so distant future it might come. The future of this is not even as distant as I thought it would be. It's even closer in some degrees. I hope not the future that is described in this book, but still I think it shows that it's a pretty current theme, pretty current also in the technologies that are described there. So if you're really interested in scientific topics or sci-fi topics, then I really encourage you to read it. And also it's not a pure science fiction novel. It's also a lot of spies and of adventurous stuff is in there. So if you enjoy these kinds of novels, then I really encourage you to read it. And I would really like if you would order the book. And of course, if you have already ordered it and read it and you liked it, then I would really encourage you to write a review, such that other people will know what the book is about and can see if this book is something for them. So this was the physics, I think, or some introduction to the physics behind this atomic bomb that was created in the Manhattan Project, and also later in later projects of the atomic program of the US. And what I found most interesting about this Manhattan Project was that there were so many brilliant scientists that came together there. If you especially see it later, many of those received Nobel Prizes for their research, not on the atomic bomb, but on parts of particle physics. For example, Enrico Fermi was a physicist who for his work on nuclear fusion received a Nobel Prize, and Richard Feynman was a physicist there who received a Nobel Prize for his work on quantum electrodynamics, and many brilliant physicists were gathered there together. And what excites me most is the stories that are told that occurred there in these times. For example, Enrico Fermi was really known for his great way of making estimations, and there is this area of what you call Fermi questions. Those are questions that you can state where you cannot immediately know the answer by just putting in some equations and calculating it out, but where you have to make some assumptions, where you have to make some estimations, some smart estimations, educated guesses to come to a close approximation of the result. For example, one was that we had in our when I started studying, it was one of the first homework I got was on these Fermi questions, and one of the question was how many dentists are there in Germany. And the way you can estimate this is you can say, for example, okay, I know there are about 80 million people living in Germany, and then you can from this conclude how many. So in Germany it is recommended to go to the dentist twice a year, and then you can see, okay, how many appointments would be needed to cover all Germans who go to the dentist twice a year. And from this you can kind of estimate how many dentists there would be needed. And then this is how I calculated it. And what I missed is that, of course, not every dentist is working overtime and so on. So there is a little bit less dentists, a little bit more dentists than this absolute number of at least needed dentists. So I think in Germany, it's about 80,000 dentists that are working there. But this is, I think I was in the right ballpark. I was at some 10,000s of dentists. So it was pretty accurate. And Fermi was really an expert on this. And this was shown in the fact that before the first atomic bomb was tested in this Trinity test in New Mexico, he started making such estimations about how much the impact will be, what it will look like, and all these questions. And using his technique, he estimated it, and in the end, he came pretty close to the actual results. So this is pretty interesting. Also, if you know about Richard Feynman, who really is, especially due to his Feynman lectures later and his unique way of looking at physics, he is really one of the stars of physics, or one of the greatest minds since Einstein, many people say. And if you have read his Surely You're Joking, Mr. Feynman, so it's kind of his autobiography where he tells about anecdotes about his life, also his life in the Manhattan Project. And there are many, many interesting stories about that. For example, he used to write letters to his wife using a secret language, and then he needed to decrypt it to the secret agents there, who were concerned about the security, about the no secret information got out of there. And so he had, because he did these games with his wife, he had to explain to them what he was writing there actually. And what he also came up with in this time, he started the walls they had there. He started to hack them, to hack the locks and so on. So he was a really interesting character. And what's one interesting part, so in the movie Oppenheimer, he's not really part of it. He's kind of standing there and does not say much. But I think one part was really covered in the movie, and this was shows how much of an understanding and a deep trust Richard Feynman actually had in physics, because when the atomic bomb was tested first, everyone, as you can see in the movie, everyone is picking up his glasses to keep the radiation from harming their eyes and so on. And Richard Feynman did not do this. He wanted to see the explosion in its fullest, but he of course also wanted to protect himself. And what he said is, okay, I know from physics that all this harmful radiation, this UV light and so on, is not able to pass through glass. So if you know the spectrum of light passing through glass, it's interesting that the UV light is usually completely blocked out of it, and Feynman knew that, and so he just sat in a car where there's a windshield and there is a glass to protect him, and he looked at the explosion without putting any protection glasses in front of him. So this shows what a deep understanding of physics he actually had, and also a trust in the laws of physics that he knew so much about. So this I thought was really also interesting. So I really, if you want to know more about Richard Feynman, I really recommend you to read his book. It's really entertaining, really amusing, also to get deeper into the thinking of him, how he thought, how he was thinking about the world, because I think he had many right ideas about science and how science works, which is why I also cover much of him or much of his thoughts in my book, Sci-Faith, the compatibility of science and faith. So in the beginning, there's always a quote of some scientist or believing scientist, and many of those are from Feynman himself, although he himself was not believing, but still he had, I think, a lot of ideas about science that were pretty fitting or pretty accurate. And also, therefore, in a later episode, I plan on covering him there, covering his ideas, his statements, as I did also sometimes before when it fitted to the topic of the podcast. But I really encourage you to read more about him. And if you want to learn about he teaches physics, I really recommend to you the Feynman lectures. He dives in really deep, so it's really, it's meant for physics students, of course, but I think there is something like, it's called 6 Easy Pieces, where you basically get the introductory part of these lectures and the easy parts, the parts that are more easy to understand. So if you say, I don't want to dive in that deeply, then I recommend those to you. And then you can really grasp the thinking of him, how he understood things, and in which way his genius kind of worked. So it's really really encouraging to read those. So that's everything for today's episode. I hope you liked it and you enjoyed each part of it. If you want to get in touch with me or discuss a topic or want to give me some feedback, then feel free to contact me using the contact form on my website, sci-faith.de/en. And there you can go to the contact tab and contact me. And if you have any other things or episodes you want to have covered there, or topics you want to have covered, feel free to contact me there. Also, if you are not yet familiar with the format in which this podcast is produced, let me just briefly explain it to you. So there is always at the beginning of a month or of a block, there is a big block of 4 episodes in one thing. It's kind of like a preview, which I call it, where you have the next 4 episodes all in one episode together, combined. And this is for people who like to hear long format podcasts, who have a long way to work or something else, where they can listen to a long episode and can then have a preview of the next 4 episodes all at once, and are completely up to date from the beginning of the block. For those who like their episodes shorter, who prefer it if they have a half an hour or even less of a podcast episode, for those there is every week afterwards will appear a podcast episode almost in that length, and this way I can publish every week a new podcast every episode, and everyone can have it his own way, either once a month a long chunk of content, or once a week a shorter format podcast episode. So I think that's the best way for everyone, and also for me when I'm producing it. Please also note that this is an independent podcast, which means that it is recorded, produced, and marketed by me. So I really need your support in this. So if you like this podcast, then give it a 5-star rating. And if you have the time, even write a review to it. This just helps other listeners to become aware of this podcast, and then people who might be interested in this content can become aware of it. Also, if you have friends who you think would like this content, then recommend it to them and share it with them. Also, you can support me in other ways, for example by reading my blog and subscribing to my newsletter, or even by reading my books, which you can find on Amazon. For example, there is my latest novel out now is Alien Thoughts, which is pretty entertaining from the feedback that I gotten, and so it's also in some way related to science and faith. The topic of it is also in there, but of course you can also read the book to this podcast, Sci-Faith, The Compatibility of Science and Faith, which is also available in English since last year. Thank you for that, and now I wish you a wonderful day, and I'm looking forward for you to tune in again next time.